problems. If someone has a tendency to write some sort of, they've learned that the typical pattern is good for them and they are overusing it. Say that they've come to the realization that Java's memory model is dangerous. And the way to solve that is to make every field volatile. I've seen that happen. So they write every field they have in any class, they type the volatile keyword before. And they run into issues, of course, and they run into performance problems. And it's really not something we can attack because they told us that it should be volatile. So a number of those kinds of structural issues where people are doing the wrong kinds of things, we can't really attack. And I see a lot of those problems happening for our customers. So we have two choices here. Either we can say, okay, so they are stupid users. We can do what we can do good, and then they have to solve their problems. We're not going to try to help them. Or we can expose these problems to the developers and help them solve the problems. And that's the approach that I want to take. Okay, so let's look at these large systems and why we need to do the translation for the developers. Why we need to do some more processing than just giving them the performance counters. In a large system, I think we all know that it's hard to find bottlenecks. One of the problems is that no single developer knows the whole system. It's a system of a couple of million lines of code. I mean, how can we expect one single developer to know the whole system? So there's no one that has this complete knowledge of the whole system and where all things are and how they're supposed to work. The project, in this case, this large system, is definitely using third-party components that they've never seen before. There's an XML parser here, there's the database connectivity layer, there's this business processing engine that they're using. A lot of different components that they've taken from a number of different places and combined. They're running in the app server if it's WebSphere or WebLogic server. And on top of this, they've written some small pieces of code that is probably 10th or 100,000 lines of code. Even more interesting is that these third-party components are using other third-party components. And in these large systems, it often happens that many of these third-party components have never met each other before. This is the first time that they are combined in an actual system. So we have a very complex scenario of a lot of components that haven't seen each other before. And of course, it's going to be hard to diagnose problems in this scenario. So let me give you an example. I've recently been looking a lot at memory leaks and memory leak-related scenarios trying to help people. Well, I had a customer, he told me he had a memory leak issue for a month. And he had been trying with all these developers trying to locate what was this memory leak. He had no idea. I went in with some of our tools and I started to tell him, well, you have this class called AAI, and it has this field, ABC. It's a hash table, and you're putting things in that, and it's just growing and growing, and you're never removing anything. Must be something wrong. He was like, I've never heard of a class called AAI. I told him, well, it sounds like an obfuscated name of some kind. The call trace here tells me that there's this system called XYZ that is using this, where XYZ was some sort of product name. And he was like, oh yeah, that's a sort of third-party component that we're using. I'll talk to those vendors. And a week came by, and he told me the story that, well, we found the problem now. We talked to this vendor, and he told me that, well, it was a known problem, and it was fixed in a later build. So we just upgraded, and the problem went away. And he had spent 1 month looking at this problem, not knowing how to continue, because there was no tool. He used all the profiles that existed. The profiles just crashed and burned, or the VM crashed and burned, no matter who. Well, it depended on, basically. The profiles were too weak. He couldn't see anything. He couldn't find anything. He found these strange classes. He had to go back to the third-party vendor to find the solution. And this is reality. So I think we need to change perspective. The normal user doesn't know what happens underneath her. And we've done a very poor job of explaining to them what we're doing. So I think that this abstraction has become a burden. We provide some performance counters, we provide some performance metrics, but they can't really tell what it means. I mean, if I tell you that I garbage collected for, say, 15 minutes, or say my garbage collection process took 900 milliseconds, what does it tell you? If I tell you that I spend 500 milliseconds in my lock code, what does it tell you? So somehow we have to give the user more information about what is going wrong, and we have to work with the upper layers so that they can explain, so that they can communicate downwards what is going on. So what kind of data am I talking about that we need to expose? It could be things like execution data, method profiles, where are we spending time in our methods, lock contention data, memory leak information, who is holding on to who, etc. It could be pause times, it could be cache misses. These are the raw data that I want to communicate, but we need to transform them using tools so that they make sense. Comment on this. I mean, the nice thing about this data is that we already have it. This is what we do for a living. We do adaptive optimization. We collect this data so that we know how we should what kind of optimizations we should do. So it's fairly simple for us to provide this data. So we can provide this in production because we already have the data. Just going back to JRocket then and looking at what we've done so far and where we're going. We have this little tool that's called the JRocket Runtime Analyzer. It started off as an internal tool that we wanted to have for internal purposes. We wanted to collect profiles of customer applications that we could use for our in-house development, deciding what to do for the next release, what were we going to work on. So we created this poor man's profiler that basically saves out a lot of the information that we have for adaptive optimization decisions out to disk. So at production time, anyone can just basically link up to the VM and tell it, do a recording for 120 seconds or 3 minutes or 5 minutes or something. And you will get a file output that includes a lot of statistics about what went on. And then you can send back the file to us and we collected these files. We started looking at it, we realized that there was a lot of the data was pretty useful to the customers too. So as it ended up, we now also have one of these very simple graphical tools on our website that you can use to view this data. Another area that we're working on that we're not ready yet is the memory leak detection problem. We're trying to expose better memory leak information up to the user. So getting back to this memory leak situation, I have another customer, and the problem he was having is that he was running very happily for a month or so, and then everything just went blank. And he looked at his logs and he found that, well, someone was saying that he had not a memory error. He started investigating this. He found out that the leak was roughly 2 kilobytes per day. And he was like, how should I find this? He installed all the profilers and they crashed and burned. And that led me to believe that we need to be better at providing production tools so that you can monitor what's going on in production. So we need to be able to answer questions like, is this application growing? Yes?
Do you think that he would be satisfied if the monitoring in his production, when he turned the monitor on, he needs to have 4 gigs of machine on his machine instead of 2 during the time he's monitoring, or you can't even afford that?
No. Most of the time they can't.
Because, you know, production for you is development for him.
This is probably in production that this is happening.
Yeah, but I mean, it's one thing to say that the tools are too weak so that they just can't cope at all with the production size heaps. But it's another thing to say that you're not allowed any overhead at all.
You're allowed overhead, but you're not allowed the same size as the heap. I mean, 100 megabytes would have been fine in his case. So there are a number of simple
what
questions.
What about stuff on disk?
How?
I mean, I believe that dumping a log to disk, you could easily exceed, your 100 megabyte allocation. It wouldn't bother people that much.
Absolutely, I agree.
Okay.
So there are multiple ways of solving it. In addition, I think we must be able to give this to the user at any time. It has to be in production. If you think about this, we have to be able to answer, are we leaking? We have to answer the question, if we're leaking, what are we leaking? And we have to explain the chain of events, who is holding on to this. But you can also extend this, and you can expand on this, and you can pretty easily realize that as we are the VM, it's fairly easy for us to tell the user when this structure that is holding on to everything gets updated. Well, this will give the user an even better idea of where the memory leaks are. So this is an area where we're working hard right now trying to improve. The final example is exposing the memory wall. We all know that memory latency is becoming more and more of a problem, hard to attack. We know that as virtual execution environment specialists, but we do nothing to tell the VM about it, or to tell the users about this. I don't know any tool that expresses cache misses on a source line basis. There's no way for an advanced skilled J2E developer, as far as I know, to see where the cache misses are. Yes,
so, I mean, there's a challenge there because even if you expose it up to the source line, you still have to figure out what to do about it. So the question is, especially in a situation where you've got a heap where the programmer doesn't have any control at all over where the objects end up. What do you do even if you know that there are cache misses on a given line?
Yeah, so Cliff wants to
usually it's an issue with your data structure that's causing cache misses to be hot at some point. You're striding through a giant array, or you've got some vast linked list that's taking a miss at every chain down the list, whatever. It's a data structure algorithmic issue. It's not randomly bad, like it's nailed you and this hot object has landed on that same cache line with some other hot object and now they're ping-ponging each other. That's going to be way more rare.
Well, we should let him have the time. We'll have time for questions.
Sure. Okay. So I think we can do more. And what I'm saying is that we're 50 VM experts here. There are probably 300 or so VM experts, say. And I think there are more people that can understand cache misses and do restructuring of the structures. So just broadening the audience a little bit, I think would help. So finally, what I want to come up to is that we need to have a better communication between the upper layers, the lower layers, and the virtual execution environment. So let me give you some examples. A good example is in Windows, there's this WMI, Windows Monitoring Interface, that allows me to define new counters within the operating system. So by adding a new dynamic library, I can make sure that JRocket counters are exposed to the operating system. So this means that the normal operating system visualizers, the perfmon in this case in Windows, can see both operating system counters as well as JRocket Java virtual machine counters at the same time in the same windows, which is a very nice property, I think. Then we can take the JSR 166 Java utility concurrency package, which I've talked to Doug about, where I'm a little bit afraid right now because we've introduced a number of new locking sequences, and there is no easy way for me as a user or as a VM to know that that's really a lock. Yes, I can do some sort of method matching and see that this has this name, but it's hard for me to explain to the user that this means that he's holding on to a lock here, or do some sort of computations on how long did he held this lock, and things like that. So we need to get better at communicating these kinds of things and exposing these things to the user, is what I think. And the same thing goes the other way around. We should provide the right ways for the upper layers to communicate to us what they want to communicate. And that's, I think, is a challenge for us that we have to solve somehow.
Okay, we're well on time. We're maybe a minute early. Any questions? Then I have one remark. I didn't feel like I should jump in to the fray in the middle of your talk. I mean, this bit about finding out where the cache line misses are, it's just a first step, because you're certainly not going to know what to do to fix your cache line